our notes today, we're starting with an algebraic concept. Notice that comparison property at the top of our notes. If A equals B plus C and C is greater than 0, in other words, C is a positive number, then A must be greater than B. And I know there's a whole lot of symbols and letters in there, but think about it rationally. If I have to take a positive number and add it to B in order to get as big a number as A, it should make sense then that A is greater than B. What they're wanting us to do in this lesson is take that property and apply it to a theorem that we've seen before, the triangle exterior angle theorem. If that's kind of fallen out of your head since chapter 3, let's stuff it back in there. You probably want to draw the diagram so that you remember it more thoroughly. Remember that the exterior angle theorem said that if angle 4, yes ma'am, you didn't get notes? Okay. If angle 4 up there is an exterior angle, it will equal the sum of the two remote interiors. Okay, so if I label them over here, angles 1 and 2, remember the triangle exterior angle theorem told us that the measure of angle 4 equals measure of angle 1 plus measure of angle 2. In general terms, we would say that the exterior angle equals the sum of the remote interiors. Now look at this equation here and think about it along the same terms of that A equals B plus C. If I have to add up my two remote interior angles to get an angle as big as my exterior angle, then what relationship exists between the exterior angle and either remote? Absolutely, that's exactly where we're going with that. So, an exterior angle is greater than either remote interior angle. That's a very small portion of our lesson today. The biggest portion of our lesson today has to do with the relationship between the sides of triangles and the angles of triangles. So let me sketch for you triangle ABC. In which AB is very clearly greater than AC. Now the point that I want to get across here is that there is a very close, very tight relationship between what side is greater and what angle is greater. You heard me mention to Taylor that the idea of an angle opposite side is very important to us in this lesson. Based upon all of that, what do you think AB being greater than AC tells us about the angles in this triangle? Two angles. An inequality relationship between two angles, Maddie? I think I get what you're trying to say. However, remember that you name angles with either one letter or three. Angle B is smaller than C. Let me make sure that I'm using the same kind of inequality sign, though. I would say that angle C is greater than angle B. Okay. Let's silence that, please. So in other words, in plain teenage speak, the main point that I want to get across to you is that in a triangle, the longest side is opposite the largest angle. And that should just make sense. Like I said, I'm hoping it's very intuitive, yes. Oh, yes. Not removed from the screen. Let's take a look then at problems 1 and 2. In problem 1, they are asking us to explain why angle 1 is greater than angle 4. Well, look at angle 1. Notice anything about it? It's an exterior angle. Okay, so measure of angle 1 is greater than, whoa, but is angle 4 a remote interior angle to that triangle? No, it's not. Okay, so what is angle 1 greater than because of that exterior angle inequality? One person, please. What is angle 1 greater than, Sarah? Angles 2 and 3. Now here's a question to you. Which of those two angles is important to us if what I'm trying to say has something to do with angle 4, Catherine? Why? Absolutely, right? So we're going to start off by saying that angle 1 is greater than angle 3 because of that triangle inequality theorem. And then Catherine made the observation that the measure of angle 3 will equal the measure of angle 4 because of the vertical angle theorem. And then finally, yes, I can say that angle 1 is greater than angle 4. Why? What am I doing to those two expressions? One is an equation, one is an inequality. What am I doing to them in order to condense them down into one statement? Your heart's in the right place. Transitive property either has to do both with inequalities or both with equations. This is substitution. But absolutely, you are on the right track. Now, in problem 2, I'm sure some of you see it very, very easily and are just ready to shout out the answer. However, I want to make sure that if you need that step-by-step thought process, you've got that step-by-step thought process. This problem is asking me for the longest angle. None of my angles are given, but I can easily pick out where my longest side is. So, what is my longest side in this diagram? It's segment AC. So, since the longest side is AC, I would hope that now it would be very easy to tell that the largest angle therefore has to be, what other letter is in that triangle? B. Angle B, yes. Just so that you'd realize that's the bottom line answer. There's a your turn. Oh wait, no. There's a your turn for problem 3. Let me do problem 3 first. Okay, we have from the screen what we need. Looks like, but wait, there's more. Problem 3 is it's just asking you in the opposite order. It's giving you the angles and it's asking you about the sides. Right? So again, step by step, let's list the angles in order because that's easy. What are the angles in order? N, and then L, and then M. Now, I know for some reason some students struggle with looking at a triangle, looking at an angle, and identifying the side that is opposite it. So let me make it as plain and simple and crystal clear as I possibly can. Triangle has how many letters? How many are in each of those angles? In each of the angles, there's one. The side opposite each angle is the other two letters of the triangle. So, what are the other two letters? LM. Other two letters? Other two letters. And once I had this, I wasn't even looking at the diagram in order to get that red line. Okay, now please take a moment and look at your turn. I know it's not as easy and convenient to do as when you're in your nice cozy groups, but do kind of look over to later and sit back. Yeah, they're always going to give you enough. Right. You should be either ready or pretty close to ready to take a look at the answer and explanation for the your turn in problem 3. If you weren't, just kind of avert your eyes until you've done your necessary calculations. If you're looking at your paper and you're looking at my screen and we are not in agreement, I'd be happy to explain myself if you need me to. Good? No? Yes, ma'am. The problem was asking us which side. Okay. No, that's all right. Always read the question. Any other questions up there? Yes. Okay. Let's go through the line of thinking. I know angle 1 is 130. I know angle S is 24. And when I add the two angles, I know and subtract from 180, I find that X is 26. That means that angle S is my smallest angle. It's going to be opposite my shortest side. The other two letters of that triangle are OX. There it is. Yes. Roll right here. Okay. Another inequality property that we deal with in this lesson having to do with just one triangle is a property that must exist in order for three segments to form a triangle. Because realize, and some of you may have thought, if I just go in the way, certainly you probably never actually thought this, but given the statement, you'd probably think that if you grabbed any three sticks, you could probably put them in a triangle. However, you can't. A specific property must exist in order for those sticks to actually form a triangle. And that's that property that you see on the screen. The fact that any two sides must be greater than the third side. Put another way, if the three sides of a triangle are A, B, and C, then A plus B has to be greater than C. B plus C has to be greater than A, and A plus C has to be greater than B. If it equals, then it's not. Good question. Say again? Think about it. In an equilateral triangle, let's say the three sides are all 2. 2 plus 2 is greater than 2. Okay? All right. Now, Some of you might be looking at these three inequalities and thinking to yourself, oh, this sounds really, really tedious. I'm going to have to check every single one of those eventualities in order to determine whether this is a triangle or not. My answer is no, because it should just make sense to you. The only one that you need to check is take your two shortest, add them together, and make sure that it's greater than the longest. So, taking that into consideration, in problem 4, we're being asked, can a triangle have these side lengths? In part A, will those three numbers form a triangle? Yes, because 6 plus 8 is greater than 13. So yes. How about part B? Will those form a triangle? No, because it equals. Sometimes you'll be given two sides of a triangle and asked, can this other number be a side? Or you'll be asked, give a range of possible values. You'll notice that in your notes, I've added this little tidbit, that the third side has to be greater than the difference and less than the sum. So if we look at problem 5 from your notes, I'm given that two sides are 10 and 18, and I am asked for the range of possible values for the length of that third side. So if I consider that third side to be x, and I've told you up here that the third side has to be greater than one thing but less than another, I'd hope that you'd kind of get an idea x is going to be in the middle of a compound inequality. I know that those are terms that we haven't used yet here, but you should have used those terms at some point last year in algebra. This is what I mean. X has to be greater than some number that we'll figure out, and it has to be less than some number that we have to figure out. Right? It has to be greater than, according to that, the difference. So what's the difference? 8. And it has to be less than the sum. So what's the sum? 28. That's it. That's the range of possible values for the third side. That's it. That's all you have to do. Kristen.
How did you get from 10? Oh, you subtract them? And then, so, how did you get 20?
Remember what these words mean. Difference means I'm subtracting the values. 18 minus 10 is where we got this 8 from. Sum means I'm adding the values. 10 plus 18 is where we got the 28 from. Okay? You have a your turn for problem 4 and a your turn for problem 5. I'll be activating the daily quiz on Socrates. Do those your turns first, though, please. However, their included angles are not congruent. I would hope that you'd realize that one angle is greater than the other. Now, I know some of you see things fantastically quickly, and I admire that so much about you. Don't let that, however, intimidate those around you. Let's make sure that we have enough time to really think and process. Look at the triangles. Look at the statements. Which one must be true? I'll see your hands now. Taylor.
I don't have paper.
Ah, sorry.
Doesn't excuse you, what's the right answer?
God.
Okay, Hope.
D.
It is D. Because AC is opposite this 98-degree angle, whereas RT is opposite this 90-degree angle, yes, statement D is the true statement. Problem 2 looks very much like Hope and myself up here, looking like cheerleaders. Which cheerleader's hands are further apart? Cheerleader A or cheerleader B? Everybody.
Uno, dos.
Cheerleader B. Pretty simple so far. And then the numbers come in. Right, Taylor?
What?
It's always so easy, Mrs. Clouse. And then the numbers come in.
Why are there numbers?
Why are there numbers? All right. In problem 3, we're being asked for a range of possible values for x. Once again, notice that these two triangles have two pairs of congruent sides. However, their third sides are not congruent. So what then would be the relationship between that 4x minus 8 and the 90? What inequality could I write relating that 4x minus 8 and the 90-degree angle?
4x minus 8. Something.
Isa,
Less than 90.
Yeah,
it's less than 90
Good job picking up my slack, Ethan.
because it's opposite the 7, whereas the 90 is opposite the 9. However, notice that the instructions are asking us for a range of possible values. Just like in yesterday's notes where we had x in the middle of a compound inequality, we're going to have x in the middle of a compound inequality here, which means I need something on the other side of this inequality sign here. What, ladies and gentlemen, is on the other side of this inequality sign here?
Would you sub?
I need a number here.
Would you sub? I don't know. Is it like what we did before, but instead we do that?
Hold on. We are going to solve the inequality.
So no, I mean like. No, never mind. Like how the last thing we just did, like when you did this, the x was in the middle, so
In the last set of notes, we were given the property that x was between the sum and the difference. That's not the case here. We realize that 4x minus 8 has to be less than 90 because the 7 is less than 9. But this is an angle. What does it have to be greater than? This is the smallest angle I can get. What's its measure? There we go. The angle actually has to exist. Okay, from here, hopefully you remember from algebra last year how to solve a compound inequality. You're not just adding or dividing the same thing from both sides, you're doing it to all three. So I'm adding 8 all the way through. I have 8 is less than 4x is less than 98. And when we divide everything, gentlemen, by 4, I have 2 is less than, bless you, x is less than, please double check my arithmetic, I think that's 22.5. $24.5.
No. How did you get the 8 at the beginning of that?
I added 8 to all three sides. In order to get this x by itself, think about it this way, Kristen. If this inequality didn't have this greater than 0 business on the left-hand side, and this was just an equation, how would you get x by itself? You would add 8.
Add it to both sides. Oh, right.
Any other questions on this screen? Hey, our lesson is pretty short, sweet, simple, straightforward. There's a your turn for problem 1, a your turn for problem 3 at the bottom. I'll be activating a daily quiz momentarily. Yes, ma'am. The hinge theorem is that whole, the hinge theorem says if two triangles have two pairs of congruent sides, but their included angles aren't congruent, then whatever inequality exists between those angles also exists between sides. Don't get hung up on the name of the theorem. Make sure that you can apply it.